welcome you all to my channel Infotainment, and I will be solving the first problem in this play series using DFT. Let us see the first problem. The first problem goes like this. If x of n is equal to 1, 2, 2, 1, then find DFT. So let us see what they have given and how to find it using the DSP formulae. The question goes like this. X of n is equal to 1, 2, 2, 1. Okay, and I'm supposed to find the DFT for this. So let us write the DFT formula first. X of k is equal to summation n ranging from 0 to capital N minus 1 x of n e raised to the power minus j 2 pi k n by capital N. Here capital N is 4 because the number of terms given are 4, and k always ranges from 0 to n minus 1, that is 0, 1, 2 and 3. Now if I customize the formula, x of k is equal to summation n varied from 0 to 3 because it is n minus 1, 4 minus 1 is 3, x of n e raised to the power minus j 2 pi k n divided by 4. Okay, because there are 4 terms, capital N remains to be 4, so therefore I have customized the formula. Now individually we have to substitute the values of k and I have to find. Now for k is equal to 0, capital X, k is there, so I just substitute 0 wherever k is given, is equal to summation n varied from 0 to 3 x of n. Here I am substituting 0. Any 0 multiplied by anything is 0, so e raised to the power 0 is 1, so into 1. Now I just substitute the values of n. It is just x of 0, x of 1, x of 2, x of 3. Okay, fine. Now I just place the value. See, this is at 0th place, 1, 2nd and 3. That means what? When I substitute 3 in the place of n, I will be getting 1. So I'll just substitute over here. It is 1 plus 2 plus 2 plus 1. This is 6. Fine. That means what? X of 0, capital X of 0 is 6. Okay. Next, k is equal to 1. I'll just put 1 in all the places wherever k is there. 0 to 3, x of n e raised to the power minus j 2 pi 1 n divided by 4. Though the 1 is not necessary to be written, it is always a good practice to write because the standard format which is in the formula can be easily detected, correct? Fine. Now here I'll just do the simple simplification. Here I'll just cancel. Okay, so now the formula would be e raised to the power minus j pi n by 2. E raised to the power minus j pi by 2 is since this is of the Euler's form, when I substitute in the Euler's formula, I will be getting it as minus j, correct? Since I will be getting it as minus j, the formula becomes summation n varied from 0 to 3 x of n into minus j. This n will come here, that is, it remains. Okay. Now again I'll just substitute the values of n, and accordingly minus j power will also vary. So now when x of 0, it is 1, so I'll just write 1. Anything raised to the power 0 is 1, plus x of 1 is 2 I'll write it as 2 over here, and when I write 1 in the place of n, I will be getting minus j, plus x of 2 is 2, and when I represent n, or when I substitute n in the n as 2, then minus into minus is plus, j square is minus 1, plus x of 3 is 1, so I just represent 1 over here. Then when I multiply minus j to this, okay, when this is j square, if I multiply minus j to it, it becomes minus j cube. So therefore minus 1 multiplied by j, minus 1 multiplied by minus j is plus j. Okay. Now if I solve this, I would be getting minus 2 plus 1 minus 1 minus 2j plus j is minus j. So this is x of 1. So I just note down the results whichever I have obtained so far. X of k would be 6 when k is 0, and it would be minus 1 minus j when the value of k is 1. Let us see what is the value of x of k when the value of k is 2. X of 2 is equal to summation n varied from 0 to 3 x of n e raised to the power minus j 2 pi into 2 into n divided by 4. I can just cancel it over here, 2 and 2 and 4. Now e raised to the power minus j pi is always minus 1. So therefore I can represent this part of the signal as, that is this entire part as minus 1 raised to the power n. These are very minute things which will reduce the complexities when I am calculating in the later stages. Okay, so these are minute things which we need to observe. Next, x of 2 is equal to summation n ranging from 0 to 3 x of n minus 1 raised to the power n. Now I just substitute the values over here. When n is 0, x of 0 is 1, minus 1 raised to the power 0 is 1, plus 2 multiplied by, when the value of n is 1, I substitute over here, when minus 1 raised to the power 1 is minus 1, plus 2, that is x of 2 is 2 only, so therefore I write 2, minus 1 square is plus 1, plus 1, 1 is there at the place of x of 3, so when I place 3 in the place of n, I will be getting it as minus 1. Now 1 minus 2 is minus 1, minus 1 plus 2 is, or else, now what you can do is, this term cancels, this term and this term cancels, so therefore it is 0. That means x of 2 is 0. Okay, fine. Now let us find what is the value of x of 3. X of 3 is equal to summation n varied from 0 to 3 x of n e raised to the power minus j 2 pi k. Okay, I can directly substitute over here, e raised to the power 3 divided by 4. Now here again there is another property, 2 ones are 2 twos are, this becomes e raised to the power minus j 3 pi by 2. Fine. Now here I am just making a minor simplification because it reduces the complexities in the further process. Here I have cancelled 2 ones are and 2 twos are, so that it is minus 3 j pi by 2. Now when I substitute this in the Euler's formula or simplify it, I will be getting the value as j. Okay, how do I get j? Is very simple. Cos term remains 0, and when I expand it, it would be minus j sine 3 pi by 2. Sine 3 pi by 2 is minus 1. Minus 1 into minus j is plus j. So this entire term would represent j raised to the power n. Okay. Now once I substitute the values of n here, it would be 1. J raised to the power 0 is 1, plus 2 into j raised to the power 1, plus 2 into j raised to the power 3 is minus j plus 1 into, sorry, j raised to the power 2 Now let us just simplify and substitute the values of n. 1, j raised to the power 0 is 1, 2, j raised to the power 1 is j itself, plus 2 into j raised to the power 2 is minus 1, plus 1 into j raised to the power 3 is minus j. This value will be again 1 minus 2, which is minus 1. 2j minus j is plus j. So this would be minus 1 plus j. So this is how you find the DFT of a simple sequence 1 2 2 1, and the DFT happens to be 6, minus 1 minus j 0, minus 1 plus j. Thank you very much for watching the video. Hope you have liked it and hope you have found it informative. Please share your views in the comment section below. If you haven't subscribed to my channel yet, please subscribe and do press the bell icon so that you will be notified when I upload my videos in the future. Thank you.